Yeah. All right. Yeah. Test. Okay. Yes. Hi everyone. So before I go about my presentation, I'll just quickly introduce myself. I'm Jia Ming. I'm from the Built Environment Technology Alliance team. Just a very quick introduction to what we do. So over the past 5 years, our role has also evolved to that of an industry developer. We have also, more often than not, been gearing the industry for transformation along the lines of digitalization, productivity, as well as sustainability. And we do so through many program levers, of which BM is actually one of them. So BM actually stands for the Built Environment Accelerate to Market Program. Yo, what up? Yeah. Built Environment Accelerate to Market Program is an open innovation program. So what we do is that through this program, we gather problem statements from the industry firms to better understand what are their industry pain points. And from there on, we also match innovators like your startups as well as your SMEs so that they can work together with the industry firm to develop solutions to solve some of these big industry challenges that you see along the way. Coming from a VC background myself, when I was wearing my investor hat, more often than not, I noticed a lack of product market fit when it comes to a lot of these startups. More often than not, you have a solution looking for a problem to solve. And that's not exactly what we want. What we want is actually the other way around. Problem statements looking for solutions to address them. So I think it's through this open innovation program that we have managed to garner quite a lot of interest. We have also seen, we have also allowed this whole built environment ecosystem to mature to the point that industry firms are increasingly more mature in leveraging upon open innovation programs to advance business outcomes. We realize that the whole industry has also matured to the point that they are more increasingly adept at using open innovation programs to advance their business outcomes. So today I'm here to share about a success story, first and foremost, from our previous cycle, cycle 5, of which M. Moser, as well as Cloud team was involved. So M. Moser, the guy behind M. Moser, Jason, is right here in our midst as well. Amazing guy. You guys can talk to him more to find out about this project as well. Yep. Just give me a sec. Yes. So context of this Cycle 5 project is is more of how we can automate cost estimation and compliance checks. I'll dive into the problem statement later on, but yes. To keep it very concise, the innovator that worked on this was a Cloud team. The challenge statement owner was M. Moser. And this was one of our Accelerate Solutions development phase. To make it simple for everyone, this like the deliverable of an ASD project is to deliver a prototype or an MVP at the very minimum. Yep. So the context of this problem statement was that traditionally, when it comes to quantity takeoff, a large portion of the industry practitioners, particularly within SMEs themselves, they often rely on traditional and manual QTO methods. And most importantly, many people are still constrained by two variables that we see here, and that is cost and complexity, especially when it comes to adopting premium BIM software. So the solution to this was that Cloud team and M. Moser, they worked together to develop a solution called Quanteam. It was really meant to plug the productivity gap where they were committed towards reducing the quantification effort, mainly through the use of deep machine learning. And what they did, which I find amazing, was that they worked out over 20,000 images, such that they have a substantial data set that they can work with. Yep. So without diving too much into the technicalities, here was a very brief workflow that we see right here. Yeah. And through this project, the project team initially committed to what you see on your right, 50% improvement in all these metrics. And I think they really exceeded expectations. What you see eventually was that across the board, across the various performance metrics, the product itself exceeded expectations. Yeah. So very quickly, this is how Quantum works. So this was the workflow that I asked the cloud team as well of how it works. Broadly speaking, you just have to upload your layout drawing, you run your prediction via the model, and then you view your results in a visual overlay, and then manual intervention functions, and eventually you export it in a file format that's compatible, whether it's CSV or Excel. Yeah. So that was one of the success case of our Cycle 5 project, and this was part of our Open Innovation Program called BM. And previously, you know, I alluded to how the industry is increasingly adept at using open innovation programs to advance business outcomes, and I think MOSA is actually one of them, but there are many more as well, the likes of CDL as well as CapitalN. So with this, against this backdrop, we at the beta team, we're also increasingly looking at other options that we can tap upon. Are there any other sort of levers? Are there any other sort of mechanism we can leverage upon to encourage our firms to partake in open innovation program? So an additional mechanism that we have increasingly come across is aside from the BM program, we've also come across the IMDA OIP. And here's just a very wide overview of the differences in how these two programs work. The point of me sharing about this IMDA OIP is also an additional, is for everyone to consider, especially if you're an industry firm yourself or you're a practitioner and you realize that increasingly you're looking for platforms to onboard onto where you can conduct open innovation. The IMDA OIP program is actually one of your options that you can also come upon. Yes, the only exception is that slightly different from our BM program, the IMDA OIP, we do encourage what I call skin in the game. So if you're an industry firm and you're working with a startup to develop a solution, we do encourage you as the problem statement owner to contribute a little bit of money to also assist in the development as well. You can kind of think of this as co-investment in the solution that you want to see. Yeah. And I think with greater ownership, I think that also translates to greater quality as well, greater clarity of the problem statement, but more importantly, greater quality of the solution that you develop. Yeah. So broadly speaking, this is the IMDA OIP timeline that you see as well. So actually this year we're actually thinking of partnering IMDA to bring forth more built environment firms on board this their upcoming core of the Open Innovation Program under IMDA. So under this program, they do allow you to have access to a wider pool of solution providers as well. So I think it's with that increased competition, you would also see better quality of solution providers that come forward as well. So yeah, this is just a very quick sharing on my end. I'm open to any questions. But if there are any questions that I may not be able to address at this point in time, allow me to get back to you as well. Yeah. Yes. So with that, thank you so much for your time and thank you so much for your attention.
Hi everyone. So my name is Jia Hen. Presentation today is more on the process itself. I won't share any POC, but it's just I do use some of the examples that is listed in the problem space that is listed in this hackathon. Just an example. So, but the main focus here is the process itself, how to focus on the problem space, how to identify the issue itself, then eventually go to solutioning. And then this whole process, I'm using Cloud Code to do it. So there will be a lot of skills, plugins that I will be mentioning that might be useful for you guys to test it out. So this is just a framing of what I'm going to present later. So we can build faster and faster. So, but faster execution on the wrong problem will just give you a wrong answer. So a lot of times nobody is looking at the stakeholders, map out the stakeholder. Nobody actually trace the cause and effect of the solutioning that you created, the incentive and all that. And nobody actually framed the problem before writing the prompt itself. So this particular process is more towards the solutioning space, then eventually go to, the problem space, then go to the solutioning. Right. So this is usually how I will start. Let's say I've been assigned to look at a certain problem. This is usually my process. So I usually, this is a relatively new thing called MVK that is suggested by a person, one of the OpenAI founder, AK lah. I call him AK. But basically it's a very effective way to actually read all the different sources. So the end result looks something like this. So you basically throw all the things that you have. Like, for example, let's say you got some like fire code policy thing. Just throw everything in. Think of it like those kind of like, have you guys used those kind of Google Notebook LM? Something along that line, but you just throw everything in, right? So that you can build out the context, right? So, and then the first part is more on ingesting, and then of course you can retrieve information from it also. So this is the way that I currently do it this way. So it's quite effective for me. And then after that, they throw in all the information already, like for example, all your policy and all this kind of thing, and how you structure your input and etc. Then we go to the next step, which is the system thinking part. So if you look at the code, maybe it's not too clear, but you can look at the events. Then we'll look at the event structure. And then after that, then you go to patterns. Then you extract out things that's important, and then do a system thinking. So this is the end result that we usually look at. It's called causal loop. So I just use this compliance and approval process as an example. So the cause and effect of this particular system. So after you get this already, then you do a 5 why. Then for this 5 why, it's easy to find out what's the root cause of the issue itself. So for example, run this 5 why, and then the root cause that it come up with this is basically, it's not too clear, is it? Basically, it actually find out the root cause, which is a data problem. The extraction is actually conflated with the reasoning problem judgment. So solving this without separating it will lead to failure. So we need to identify what is. Nobody defined what the agent need to see and what it need to judge. So that's a root cause, right? And then also we'll do a stakeholder mapping, etc. Like to map out what's the interest and etc. And then frame the problem itself, right? And then what's the constraint, what's the success, etc. And then the next step is inching towards solutioning now. It's like, how might we do this certain thing? Like make, for example, for this example, it says make building codes machine readable, and others like how might we. And all this is I'm using some skills that that can preloaded the Claude code. Then it will look at this particular thing and then do this how might we. And the end result is a go to no go, and what's the input. For example, input is a certain drawing set, and the output is what. And then go, when all this is okay, then what it means to go, right? And then inching towards solutioning, I use something called get shit done. So this is one of the road mapper. So it will look at the whole knowledge base that you build and ingest. Then we will come up with, we call it a product requirement document. So this will list down who's the user, what's the problem, what's the success criteria, etc. And then create a phase. Then based on this, then we go to the next. Actually, we already touched on this point already. So the agent itself, if you just use a really vanilla like Claude code, you cannot do too much. So you usually want to install some of the tools that you allow it to do some certain things. So for example, you can actually open up browser and then go to a certain place to check find out some information. Or there's something called Contact 7 that really look at the let's say you are using web application and certain framework that you use, then you will have those information. Right, so usually then after that we do the GSD new project, then the next step is actually planning phase by phase. It will usually start with phase 1 now. Then after that, it will create a verification criteria also. Right, and then so in the current POC that I see, there's more and more agent take like a web application now. So which means that the agent itself, you want to equip it with the right tool also. So for example, extract geometry. This is not something that is like LLM is really good at. You usually want to create a tool for that. Yeah, later I will touch on what is deterministic and what's non-deterministic. So it's easier to plan your agent so that you can use the right tool for the right thing. So you can see this example, right? So console log means that we'll just like print out this hello world, right? So this is what we call deterministic. And then the other side is non-deterministic, where you create a Claude, like an agent, and then you ask it to say hello world, and then it will print out hello world. So that is non-deterministic. Sometimes maybe you tell something else, right? That the first one is deterministic. The second one is non-deterministic. So also a lot of times that I also noticed that a lot of times you ask the agent to do mathematics where it's actually not that good. So usually for this case, the mathematics part, you want it to be a tool call. Let's say for this case, it's a calculator and then generate the result. So this is a really good example of what's deterministic, what's non-deterministic. When you're planning for your POC, you need to be quite clear about this. If not, then you will end up didn't reach the result that you want. So this is just some of the examples. Right, so for this, I just like list down some of the potential use cases, and then later I'll click on it, then it will show whether it's deterministic or not deterministic. So is corridor with this number, is this deterministic or not deterministic? Actually, is part of it is non-deterministic, and part of it is deterministic. Because identify the corridor itself is a judgment. You don't know, like in this particular drawing, or let's say IFC, where exactly it is as a corridor depends on the situation. So if it's not clearly been findable, right, that particular corridor, then this is non-deterministic. Right, and then what deterministic is like after you know where exactly the corridor, then measuring the width itself is deterministic. So this is another example also. So if there's an IFC sign tagged to it, then it's deterministic. If it's just a drawing itself without clear indication of where is it, then you need to guess. That's non-deterministic. Right. But when you find where is the exit sign, then it's deterministic already. Right, same goes with this. One sign is identified. Height itself is just a geometry. You can use tool call for that. Right, same goes with this also. Right, and this also. You can ask AI about it. And then also, good thing if you build up your knowledge base, let's say you got a few like an example, good example or bad example of your input data, then it will tell you like this particular thing. There's no easy way for you to find this particular thing. Like for example, if the IFC sign is not really tagged, right, it will flag it out. It will tell you that, okay, I don't have a deterministic way to find out this information, right? So all this need to be clear. If not, then you will keep on complaining like the LLM or your web app that you want didn't reach the expected target based on the input that you set off. So we have seen a lot of cases like this where the issue maybe is not the LLM itself, it's just the particular issue is like deterministic, not deterministic. How to make it more deterministic is the better question itself. So this one is another complex one also. It's fire exit unobstructed. Because if the door swing area is mapped out, then it's deterministic already, right? If it map out, then it's deterministic. If it's not, then it's non-deterministic. It's everyone guess. You need to infer based on the door swing itself, etc. So, right. So this one is more on the coding agent part. So LLM is non-deterministic, which means it will forget. Right. So in writing code itself, usually we will try to make it more deterministic in some way that we enforce some certain rules. So this is the natural language way to say I want my code to write in certain way. Right. But usually when we do harness engineering, because we can actually have something like a hook, whereby every time the Claude code actually write a certain, let's say write a JavaScript, then I can actually trigger it to run this particular programmatical code to check my code is aligned to what I want. So this is, with this it's easier for us to run like agent, coding agent can run longer that without drifting too much. So if you look at my Claude code, I usually set up, you use something called Claude update config. Then we'll config all this, we call it harness to make sure the coding agent don't deviate too much. Right, so this one also go back to GSD. So it's a really good tool where you can actually do the research, then planning, and etc. So I wouldn't recommend for more simpler application, more complex one. Maybe it will make more sense. Right, and then really interestingly for GSD, right, so it will finish a task. Before it starts a task, it will write something called verify.md. So basically this particular task, how do I verify it? And then very interestingly, they got their own judgment. So it's like if this task requires human in the loop, then they'll ask human. If this is something that LM can check itself, then it will do that. So this is quite interesting way to develop. So then it will do phase by phase, then complete the task itself based on the roadmap that's set, the PRD that we set previously. So this is a full flow that I usually use when I take in some of the new POC right now. Yeah, that's all for me. Any question? Yeah. For me, I use Claude code mostly, so I don't use those kind of open Claude like Soul and all this kind of thing. So I usually have something called .wiki, where I contain all the knowledge base of this particular POC. And then there I got something called .planning, whereby actually the GSD thing that contains the roadmap. Then there's something called code architecture, concerns, what's the concern of this, technical concern of this thing, and then what's the constraint. And then there's requirement also, requirement ND and all that. So the GSD part is the solutioning part. Then the wiki is the knowledge base. So these two things works quite well together. So different people got different way of doing this. This makes sense for me because you need to have a context part. Because if not, then you are just building for fun, right? Yeah, you want to ground that with always start with the .wiki. The .wiki created already with the knowledge base that you've seen something like this. So this is always my starting point where I feel like I have enough context already. Yeah, so this example of my .wiki that I created for this presentation. So I basically just read all the information that's related for this presentation, and this is the graph that is generated. This is called Obsidian. It's called Obsidian. It's just an app. Obsidian. Yeah. But it's just read all the .md file. Yeah, and then the planning part is the GSD. Thank you.